Can you see
Yes, sir.
can you see what is on the screen right now?
Yes, sir.
All right, beautiful, beautiful, beautiful.
No, sir.
How about now? Can you see what's on the screen right now?
Yes, sir.
Good, 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 good. So can everybody see what's on the screen right now?
Yes, sir.
Beautiful,
Yes, sir.
beautiful, beautiful. Dorcas, you're welcome. Francis, you're welcome. David, you are welcome. Nifemi, you are all welcome. So let's get into what we have. We started by talking about electronic configuration in our previous class. We talked about we talked about electron shells. We talked about a few things that are very, very important. And then I showed you how to carry out electronic configuration. Now, in today's class, we're going to be doing the concluding part where we look at the periodic table and how it relates to everything we've been talking about thus far. Okay? So now, first things first, I want you to understand that electronic configuration and the periodic table have a connection, and that connection is what we want to see. That connection is what we call the SPDF blocks. Now, don't get confused, okay? I'm going to be explaining each and everything in detail. Before we proceed, I want to know if you're hearing me clearly. If you can hear me clearly, can I see your reaction on the screen? Just drop a reaction, maybe a wave or whatever it is. If you can hear me clearly, let me see your reaction on the screen. If you can hear me clearly, can I see your reaction on the screen? Very good. Perfect. Now I know that everybody can hear me. So the periodic table can be divided into blocks depending on which subshell is being filled. Now, here is what we mean. Here is the example of what we mean. This is a diagram of what the periodic table looks like on the screen right now. The way this periodic table is arranged, there are different segments that contain different blocks of the periodic table. And I'm going to be showing you all the blocks one after the other. I repeat, this periodic table, the way you see it like this, the whole of the periodic table has been divided into blocks. And those blocks, I'm going to be showing you what they are in today's class. So block number one is called the S block. Block number one is called the S block. Let me hear somebody say S block.
S block.
Thank you very
Yes.
much. And you can see where it is located. I have two red boxes that are showing you the location of the S block. One over here and one over here. Can you see it?
Yes, sir.
Beautiful. Now, if you notice very well, the red squares or the red um this red stuff that I have covering a part of the periodic table, there are certain elements that it is covering. Now, every element that that red block covers is telling us that the elements there are in the S block of the periodic table. So let me go back briefly and you will see something. If you notice, I've removed the blocks now, and you will see that those red blocks covered this portion of the periodic table from here to here, and then it covered from here to here. Is that correct? And then it also covered
Yes,
this
sir.
place. Good.
Yes, sir.
What this means is that if you pick any element from these segments that I just labeled for you, any elements that you pick, whether it is helium or anyone here, any element you pick, when you write the electronic configuration, it is going to end with the S subshell. Did you all get that?
Yes,
Yes, sir.
sir.
Now
Yes,
let's look
sir.
at now let's look at one example. I want somebody to pick for me any element that is inside this S block, that is from this segment that I'm labeling now, all the way to this place. Any element you want
Magnesium.
to pick, anyone you want to pick. Okay, somebody picked magnesium.
Helium.
Does anybody want to pick any other element?
Helium.
Which one?
Helium.
Helium.
Helium, okay. Who else wants to pick any other element? Okay, somebody picked
Lithium.
magnesium. Okay, lithium.
Mhm.
Somebody picked magnesium, somebody picked lithium, somebody picked helium. So let's do them one by one. We have magnesium, we have helium, and then we have lithium, Li. So the first thing to do is to know how many electrons are present. Magnesium has the atomic number of 12. Is that correct?
Yes, sir. Yes, sir.
Good. So that means we have 12 electrons. So if we follow this arrangement over here, the first arrow touches 1s. Is that correct?
Yes, sir.
How many electrons am I going to put?
2.
Because the S subshell can accommodate 2 electrons. Is that correct?
Yes, sir.
Good.
Yes,
So
sir.
what is the next thing to put now after 1s?
2s.
Good.
2s.
2s, because I'm following the arrows one after the other. So I've put my 2s now. How many electrons am I going to put?
2p.
I'm going to put 2 electrons because the S subshell can accommodate 2 electrons. After 2s, what am I going to put now? I'm going to put 2p.
2p.
Thank you.
2p.
How many electrons am I going to put now?
6.
Thank you.
6.
6.
Six.
6 electrons. Thank you very much. So how many have I taken care of now? 2 plus 2 plus 6 gives me 10. How many do I have left? I have 2 left. Good. So what's the next one to put after 2p? 3s. How many am I going to put? 2, because it can accommodate only 2 electrons. Now you can notice and you can see that the last subshell that we took care of was the S subshell. So this confirms for me, just from this information given by the electronic configuration, I can know that on the periodic table, magnesium will be located on the S block. And was that not what we noticed over here? Magnesium,
Yes,
where
sir.
is the location of magnesium? Look at it over here on the S block. Did you see that?
Yes, sir.
Good. Can we take the next example for helium? So for helium, what's going to be the electronic configuration? First of all, we need to know how many electrons helium has. How many electrons does helium have?
2.
Good. So what's the electronic configuration for helium then?
1s.
Mm-hmm.
Is power 2.
Good. 1s2. What else am I going to write?
That's all.
Good,
No.
good, good. I wanted to see if you're following and you actually surprised me. Beautiful. 1s2. And if you look very well, we started with and we ended with the S subshell. Helium is also in the S block. And then finally we have lithium. Lithium has the atomic number of 3, which means there are 3 electrons. Is that correct?
Yes, sir.
Good. So I want somebody to help me out. Nifemi, give us the electronic configuration of lithium. If Nifemi is not there, Dorcas, go ahead, give us the electronic configuration of lithium. Okay, seems Dorcas is not there either. How about you, Francis? Do you want to give us the electronic configuration of lithium?
Yes, sir.
Oh yeah, go ahead.
1s raised to power 2.
Okay,
Then
1s
2.
raised to power of 2, 1s2. Yes, what else?
Then 2s. This time is
Mhm.
raised to power 1.
Thank you very much, because we've taken 2 electrons here, and over here can only take 1 more electron because we have 3 electrons in total. So you can see this also ends with the S subshell. So telling us that all of them are located in the S block. If we check all the examples that we dealt with lithium. Lithium is located in the S block. This is lithium over here. We dealt with helium. Helium is located in the S block as well. And we dealt with magnesium. Can we all see that?
Yes, sir.
Good. Is it
Yes.
difficult?
Mm.
Is it
Yes, sir.
difficult? Good. All right. So now let's move on to the next block. After the S block, which block comes next?
P.
The P
P.
block.
Good. The P block is the one that comes next, and this is the location of where the P block is. Can you all see the place that I labeled P?
Yes, sir.
Yes, sir.
Good. If you pick any element that is in the P block, let me label it for you so you can see them. Any element that is in the P block, starting from this line that I drew over here, any element that you pick that is in the P block and you draw their electronic configuration, it is going to be located in the P subshell. Does anybody want to pick any example? And let's do that.
Argon.
Argon. Okay, argon is over.
Carbon.
Yes, who is speaking again?
Carbon.
Anyone you pick, you're going to be the one to draw the electronic configuration. No?
Okay, carbon.
Aluminium.
How- who is speaking again?
Thank you. Carbon.
Aluminium.
Okay, so we have argon and then we have carbon. How about the last one?
Aluminium.
Aluminium, Al. So let's go ahead and do them. Argon has the atomic number of 18, carbon 6, and aluminium 13. So who picked argon?
Me, sir.
Oh yeah,
Francis.
go ahead and pick. Oh yeah, go ahead. Let's do it.
Argon has Argon has 18 electrons.
Okay, so let's write it out. Argon, Ar, 18 electrons. The other ones that they picked, I hope you people are getting ready because immediately we won't waste any time. All right, so let's do it.
So we start with one S with a
Good.
small 2.
1s2, okay.
Then 2s2.
Okay, 2s2, okay.
Then 2p6.
Okay, 2p6, all right.
That's 10 electrons, remaining 8.
Good, remaining
So
8.
then 3s2.
Okay, 3s2, okay.
Then 3p6.
Okay,
And that's all.
good. So if we total it now, we have 2 here, plus 2 here, that makes 4, plus 6 here, that makes 10, plus 2 here, that makes 12, plus 6 here, that makes 18. If you notice, Francis, the last shell that was filled was the P subshell. So that confirms to us actually that argon is in the P block. Was that not what we said?
Yes, sir.
And
Yes,
if
sir.
you notice, argon is located over here. And that is the P block. Look at it. P block. Did you see that?
Yes, sir.
Beautiful. So who picked the next element? What was the next element that we picked?
Carbon. Me, sir.
Okay, who picked carbon?
Me, David.
Oh yeah, David, let's go, let's go, let's go, let's go. Carbon C. Let's go.
The carbon has 6 electrons.
Good. 6 electrons. Let's go.
Okay. 1s2.
Okay, 1s2. Beautiful.
2s2.
Beautiful. 2s2. Beautiful.
And 2p2.
2p. How many?
2.
Are you sure?
Yes, sir.
Good. So you see now, over here, 2 electrons plus 2 electrons plus 2 electrons. That gives us a total of 6. And the last subshell that was filled shows us that the element is located in the P block of the periodic table. Did you see that?
Yes, sir.
Now, what was the final element we picked?
Aluminium. Sir.
Good. Who is doing aluminium for us? Who is taking care of aluminium for us?
It was hello.
Hello?
Hello.
Hello, can you all hear me now?
Hello.
Can you all hear me now?
Yes, sir.
Yes.
Yes, sir.
All right, beautiful. That was a network glitch from my end. Sorry about that. So when we're talking about
Yes, sir.
the next element to draw the electronic configuration for, what was that?
Yes. Aluminium.
Aluminium. So who is doing aluminium for us?
Nadia.
It's Nadia, sir.
All right, go ahead. Are you ready?
Yes, sir.
All right, so
So
what's the first thing to do?
aluminium has 13 electrons.
Okay, aluminium
That is
13. That's good. All
one
right.
S, one S2,
Okay, beautiful.
two S2,
Okay, beautiful.
two P6,
Okay, okay,
three S2,
okay, beautiful.
and then three P1.
Thank
That
you.
is 13 altogether.
Thank you. So if you check out very well, you'll see we have 2 over here, plus another 2 over here, plus 6 here. That makes 10. And then we have 2 here.
Yes.
10 plus 2 gives us 12. And then finally we have 1 here. It ends with 3p1. So from the electronic configuration, it tells you that aluminium is in the p block of the periodic table. So just by looking at the electronic configuration, you can discover or you can predict where that element will be on the periodic table. So you can see the P block, and that's where aluminium is located. Did we all get that?
Yes,
Yes.
sir.
Yes, sir.
Beautiful. So the next block
Yes.
that comes is the D block, I beg your pardon. So we have dealt with the S block. We've dealt with the P block. The next one is the D block, and this is where it is located. So if I back up a little bit, you will see where the D block is located from here all the way to this point, and then from here all the way to this point. So now we can pick absolutely any element from here. And if we draw the electronic configuration, you will discover that the electronic configuration is going to end with the D subshell. Does anybody want to pick any element as an example?
Silver.
Okay, silver.
Zinc.
Remember, any element you're picking, you're going to draw the electronic configuration for us. Okay, so who picked silver?
Miss Francis.
Okay, and the the symbol for silver, that's Ag. How about
Yes,
zinc?
sir.
Who picked zinc?
Okay, sir.
Who picked
Oh,
zinc? Someone else picked zinc.
Ifemi.
Okay, Nifemi, you picked zinc. Good. So let's go ahead and do them. Silver and zinc. So allow me to proceed a little bit.
Iron.
Silver and zinc. Good. So somebody picked silver. That was
Francis.
Francis. Good. What's the first step?
We know the number of electrons, which is 47.
Good. 47. That's the atomic number. So what's the
So
first thing to do?
we start the electron configuration, which is 1s2,
Good. 1s2.
2s2,
Good. 2s2. Beautiful.
2p, 2p6,
Good. 2p6.
3s2,
Good. 3s2.
3p6.
Good. 3p6.
4s2. That's
Good.
20.
4s2. How many are we now?
20.
Good.
Then 3d10.
Good. Remember, the D subshell can host 10 electrons. So 3d10. How many are we now?
30.
We're on 30. Good. So how many is remaining?
16.
Are you sure?
Sorry, 17.
Good. Make sure you don't lose the number of electrons that you are having left so that you don't make a mistake. So after 3d10, what are we moving on to now?
4p6.
Okay, so we have 4p6. Good. What's next?
5s2.
Good. 5s2. What's next?
It's 4d10.
Okay.
Um,
Are you
it's
sure?
8. Wait, sir. Remove the
Yes.
10. Let's put 4d9.
Good.
Since if we add 10, it will be 48. So it'll be a little above what we are looking for.
Good. I wanted you to see your mistake there. Thank God you noticed it. So now let's count. It's very important for us to count to see if we are online on track. So we have 2 over here plus another 2. That makes 4, right?
Yes, sir.
Good. Now we have 6 over here. That makes 10. 10 plus 2 makes 12. 12 plus 6 makes 18. 18 plus 2 makes 20. And then over here we have 10. That makes 30. Are you there?
Yes, sir.
Good. 30 plus 6 makes 36. And then 36 plus 2 makes 38. And then over here we have 38 plus 9. That gives us 47. So we ended our electronic configuration with 4D. This is telling us that the element silver is located on the D block of the periodic table. Was that not where we found it in the first place?
Yes, sir.
Beautiful. So the next element that was picked was zinc. Is that correct?
Yes, sir.
Who picked zinc for us?
Yeah.
Who picked zinc?
Any-
Okay, are you ready now?
Yes, sir.
Are you sure?
Yes, sir.
All right, let's go now. Let's
Yes,
go.
sir.
Let's go. Zinc Z. So what's the first step?
Zinc has
Okay. Zinc has
50 electrons.
30 electrons. Good. So let's write that out. 30. So what's the first thing to do?
So 1s2,
Good. 1s2. What's next?
2s2,
2s2. Beautiful. What's next?
2p6,
Okay. 2p6. Good.
3s2,
Okay. 3s2. Hope you're counting them as you're mentioning them.
yes, sir.
Good. So what's next
3,
after 3s2?
3p6,
Okay. 3p6. Good.
4s2,
Okay. 4s2. Good. How many do we have now?
we have 20,
How many is remaining?
10,
Good. So what's the next thing to write?
3d10.
Good. 3d10. Are we moving any further or are we done?
Pardon.
Good. We are done because if you add everything together, we'll end up with the number 30, which is the number of electrons that are present in the element zinc. And if you notice very well, Nifemi, you would see that the last subshell that we took care of was 3D, and that is the D subshell. So that tells us that zinc is located in the D subshell. So you can all see that this actually applies to the periodic table. So let me back up a bit to show you where the D subshell was located. You can see it over here. Is that correct?
Yes, sir.
And that's where zinc is located. So after the D subshell, we have the F subshell, which is the final one. And over here, that's where we have the big boys. We call them the lactandites and the actinides. So you can see them located over here. Can you all see it?
Yes, sir.
Beautiful. So over here now, these are the guys that are located in the F subshell or the F block of the periodic table. We've dealt with the S block, the D block, the P block, and this is the final one, the F block of the periodic table. Any element you pick from here, absolutely anyone, it is going to end up with the F subshell being filled in its electronic configuration. Does anybody want to pick?
Me, sir.
Okay, good. Which one are you going with?
Plutonium.
Okay, Lutinium. I think this guy over here, is that correct?
Yes, sir.
Good. Who is picking anyone again? Okay, if nobody is speaking, then let's go ahead and take care of this guy, Lutinium 71. So, um, you picked Lutinium, that's 71. Is that
Ye-
correct?
Yes, sir.
Good. Can we go with that?
Yes, sir.
All right, let's begin. So, what's the first thing to do?
Lu 71.
Okay, so let's do that very quickly. Lu. It has the atomic number 71. So what's the first thing to do?
1s.
Okay, 1s2. Now, while we are taking care of this, Nadia, I want you to prepare for me the atomic or the electronic configuration of cerium. Here is the atomic number. Did you hear me?
Yes, sir.
I want you to prepare it. Once we're done, I'm going to ask you for it, okay?
Okay, sir.
All right then. So let's go. Lutetium, we started with 1s2. What's the next one?
2s2.
Good. 2s2. Beautiful.
2p 2p6.
Okay. 2p6. Beautiful.
3s2.
Okay. Beautiful. 3s2. All right.
3p6.
Okay. 3p6. All right.
4s2.
Okay. 4s2. Beautiful. What's next?
3d10.
Good. 3d10.
4p6.
Okay. 4p6.
36. 5s2.
Good. 5s2. Now, I hope as you're calling them, you're taking note of the number of electrons that are added up now.
Yes, sir. We have 48 now.
Are you sure?
Yes, sir.
We have
10, 20.
38. Over here we have
Okay, sir.
10. Over here we have another 10. Over here we have another 10. That makes 30, right?
Yes, sir.
And then over here we have 8. That makes 38. So make sure that you don't miss your count. So if we have 38, how many is remaining for us to
From
take care of?
71.
From 71, if you remove 38, how many is remaining?
35 minus 3. 32.
Good. So we
So
have
30.
71,
No.
38. When we remove
33.
we have 33 more electrons to take care of. So
Yes, sir.
after 5s now, what's next?
4d10.
Good. 4d10. Yes. What's the next one after 4d10?
5p6.
5p6. Yes. So what's next?
6s2.
6s2. I hope you're taking note of the numbers.
Yes, sir.
Good. So what's next after 6s2?
60. Okay. 60, look for 71. So 71 minus 60 will be 11. 4F11.
Now, before we put 4f11, I told you the number of electrons that each of them can accommodate. Is that correct?
Yes, sir.
Now, the F subshell, how many electrons can it take?
16.
Are you sure?
Sorry, 14.
Good.
14.
Can everybody else in the class, can you see what we are doing? I want it to be that everybody is also following.
Yes, sir. Yes,
Good.
sir. Yes, sir.
Good. So we mentioned in our previous class that the S block can take 2 electrons, the P block can take 6 electrons, the D block can take 10 electrons. How about the F block?
14
14.
14.
electrons.
Good. So at this point now, after our 6s, how many electrons are remaining for us to take care of? Yes, Francis.
I said F11.
How many electrons are
Size
remaining for us to take care of?
11.
Good. So can the F subshell take those 11 electrons?
Yes, sir.
Good. So how many do we have now? We have 4F11.
F.
So it
Yes,
is
sir.
very important at this point now, it is very important for us to do a background check. We'll check if the number of electrons are complete to 71. So let's go. Over here we have 10 electrons. Is that correct?
Yes, sir.
Over here we also have another 10. That makes 20, right?
Yes, sir.
Over here we have another 10. That makes 30, right?
Yes, sir.
Here we have 6 plus 2. That makes 8 plus 10. That makes 18. 30 plus 18 gives us 48, right?
Yes, sir.
And then we have 6 over here. That gives us 54, right?
Yes, sir.
Good. And then over here we have 2. That gives us 56, right?
Yes, sir.
56 plus 11. How many does that give us? Or does that give us rather?
67.
Are we missing something here? It's
Looks like
actually
so.
supposed to be
10, 10, 10, 10, 20, 30, 36, 37, 6, 38, 38 plus 10, 48, 40, 48 plus 6, 54, 54 plus
okay.
54.
So you can see we arrived at 67, right?
Yes, sir.
Good. How many are we supposed to arrive at? 71.
71.
Because that shows that we are not yet done.
Yes, sir.
So let's take the atomic configuration one more time so that we're going to be taking it step by step so that we don't miss any detail. So we have lutetium, Lu,
Yes, sir.
right? With the atomic
Yes, sir.
number 71. Is that correct?
Yes, sir.
For those of us who may not be following, this was where we picked it from. Lutetium is on the F block, Lu, and it has the atomic number 71. I hope we can all see it.
Yes, sir.
Good. So 71 electrons. Let's go ahead and deal with the electronic configuration. We start with 1s2, right?
Yes, sir.
Good. So what's next after 1s2?
2s2.
2s2. Now we have 4 electrons. What's next after that?
2p6.
2p6. Now we have 10 electrons. What's next after 2p6?
3s2.
3s2. What's next after that? 3p.
3p6.
Good. Then after that we
6.
have 4s2.
4s2.
Good. Then after that we have what?
3D10.
3D10. Then after that, we have
4P6.
4P6. After that, we have
5S2.
5S2. After that, we have
4D10.
4D10. Thank you. After that, we have
5P6.
5P6. After that, we have
6S2.
good 6S2. After that, we have 4F.
4F14.
So before we put the 14, let's calculate the total that we have. So we have 2 here, plus 2 here, that makes 4, plus 6 here, that makes 10, plus 2 here, that makes 12, plus 6 here, that makes 18. Are we all following?
Yes, sir.
Yes, sir.
Good. 18 plus 2, that makes 20. 20 plus 10, that makes 30, right?
Yes, sir.
30 plus 6, 36, plus 2, 38, plus 10, 48, plus 6, that's 54,
4.
plus 2, that's 56. So over here we'll put 14. 56 plus 14, let's see.
70.
Okay, so have we completed the number of electrons needed?
Yes. No, sir.
Okay, how many is remaining?
1.
Okay, what's next after 4F?
5D.
5D,
5D6.
how many?
5D1.
5D1. Let's check where lutetium is located.
Located at F.
It's located at the F block, but we are getting D. Then that means there is a problem somewhere. Hold on, I'm going to fix that, okay? But while we do that,
Yes, sir.
let's not get delayed with any delay right now. Nadia, I asked you to get me the configuration for cerium. Are you ready with them?
Yes, sir.
All right, go ahead. Did you end with the F block?
Yes, sir.
All right, give it to me.
Okay. So it has 58 electrons.
58
That is one,
electrons.
yes. That's one S2,
1s2,
2S2,
2s2, okay?
2P6,
2p6,
3S2,
3s2,
3P6,
3p6,
4S2,
4s2,
3D10,
3d10, okay?
4P6.
4p6. Is everybody seeing what we're doing?
Yes, sir.
Good. 4p6. What's next?
5S2,
5s2,
4D10,
4d10,
5P6,
5p6, yes,
6S2,
6s2, and then
4F2.
4f2. If we total all of this together, let's see if we're going to arrive at 58. All right, Francis, can you help me out as we
Yes, sir.
take the total? This is 2
Yes,
plus
sir.
2, mhm,
4,
plus 6
4, 10,
plus 2
12,
plus 6,
18,
good, plus 2
20,
plus 10
30,
plus 6
36,
plus 2
38,
plus 10,
48,
good, plus 6
54,
plus 2
56,
and then plus another 2.
58.
Now, I want to ask a
Correct.
question. From this electronic configuration, what is the number of shells that will be present in the atomic structure looking at this electronic configuration? What is the number of shells that will be present?
4 shells.
Are you sure?
SP.
Now, let me give you a trick. Let me give you a trick. To know the number of shells that will be present in the atomic structure of an element by looking at its electronic configuration, just look at the highest number there. Now, in this electronic configuration, what is the highest number here?
4.
D10.
Are you sure?
35.
Are you sure?
6.
6.
There is 6 over here.
6.
That tells us that the number of shells that will be present in the electronic or the atomic structure of this guy's serum over here will be 6. So I just brought that in for us to be clear on that. For the the electronic configuration for lutetium, I'm going to get back to us on that, okay? I think there's an issue that we're not seeing there. But basically, you've seen all of it that the periodic table is a map of electronic configurations. We saw the S block, we saw the P block, we saw the D block, and then we saw the F block. Just by looking at the electronic configuration, we could predict the location where an atom will be located. So now here are some examples, some exercises on the screen. I want somebody to do this for me. We have chlorine. I want somebody to tell me what the electronic configuration will be, and then from there tell me which block is it going to be in. Who is doing that for us?
Me, sir.
All right,
Francis.
everybody do it. Everybody do it.
Okay.
I'm awaiting the answer.
17. 2. 4. 10. So I'm done.
Okay? Let's wait for the others to be done too.
Thank you, sir. So I'm done.
Okay? Let's wait for the other to be done as well. Yes, who else is done? Who else is done?
So I'm done.
All right, good. So let me know. Which block is chlorine located in on the periodic table?
P.
Which one?
P. P.
D.
Is located
Okay.
at P.
Is located at
P.
the D. D or P?
No,
I'm hearing
P.
D. I'm hearing.
P. P.
Okay, P.
P. P. P for potato. P.
Okay, P for put. Thank you very much. P. Okay. Who else has another answer apart from that? Do you all agree that it's P?
Think S.
Okay, somebody is saying S. Okay. All right, let's find out now. What is the electronic configuration? We start with 1s2, right?
S2. Yes, sir. Yes, sir.
And then 2s2, right?
Yes, sir. Yes, sir.
Remember, the atomic number is 17. In other words, we have 17 electrons. Then we have 2p6, right?
Yes, sir.
Then after 2p6, we have 3s2. How many do we have now?
That's 12.
Okay. How many do we have left?
5.
Good. So that after 3s, we have 3p. Is
3.
that correct? 3p5.
Yes, sir.
So we arrive at this answer. That chlorine is on the P block. of the periodic table. Did you see that?
Yes, sir.
Good,
Yes,
beautiful.
sir.
So now, from this information alone, I showed you in the last class that we can use it to draw the electronic or the atomic structure of what it would look like. So let's do that very quickly. Now, we have the first shell or shell number 1. So let me write the name chlorine. For shell number 1, how many electrons do I have there?
2.
6.
2. And then for the second shell, you can see number 2 over here, right?
Yes, sir.
Good. Let me draw that out. Shell number 2. How many electrons do I have?
2.
I have 2 here. And then over here, still on shell number 2, how many electrons do I have?
6.
So let me draw that out. 1, 2, 3, 4, 5, 6. Did you see that?
Yes, sir.
And then I have the third shell over here. So I'm going to draw that out. Shell number 3. Can you all see it?
Yes, sir.
Good.
Yes,
How
sir.
many electrons do I have over here?
2.
I have 1, 2. Then over here, I have shell number 3. So I'm not drawing an extra shell again. Is that correct?
Yes, sir.
How many electrons do I have?
5.
So 1, 2, 3, 4, 5. I've drawn what the atomic structure will look like. So now the question says, how many valence electrons does he have? Can somebody count for me? Do you know what a valence electron is?
Yes, sir.
What's a valence electron?
The number of electrons in the outermost shell of an atom.
Okay, good. The electrons that are at the outermost shell of an atom is called valence electron. So over here, let's count the number of valence electrons that it has. 1, 2, 3, 4, 5, 6, 7. So how many does it have?
7.
How many does it have?
7.
Good. There are 7 valence electrons for chlorine in the outermost shell. So the next question here says, we have the full electronic configuration for phosphorus over here. Phosphorus has the atomic number 15, and this is the electronic configuration. Now, I want somebody to tell me how many valence electrons will be present for phosphorus. Without drawing the atomic structure, without drawing anything, I want you to look at this and tell me how many will be there.
I think 5.
Okay,
Yes.
somebody said 5. Does anybody have another answer?
Hello.
Yes, sir.
No, sir.
Does anybody have another answer? Yes. Does anybody have any other answer? Or you're all still thinking?
So I also think it's 5.
Okay, good.
The answer is 5.
Okay.
Yes, sir.
For all of you who said 5, you're actually very correct. Do you know why? Now look at this electronic configuration. The highest number here is 3. Is that correct?
Yes, sir.
And that tells us that the valence shell is shell number 3. Now, how many electrons are there on shell number 3? You can see over here we have 2 electrons, right?
Yes, sir.
Plus, over here we also have shell number 3. How many electrons are here?
3.
So we have 2
Yes,
plus
sir.
3. That gives us 5 valent electrons. So in summary, all we've been saying since the beginning of this lesson is we have explored the foundation of modern chemistry by studying atomic structure and electronic configuration. Were we able to learn anything new in today's class?
Yes, sir.
Nifemi, tell me, what did you learn?
I learned the periodic table blocks.
Okay, you learned the blocks on the periodic table. How about you,
Yes,
Nifemi? What did you learn?
Uh,
Nifemi, are you there?
is muted.
Hello, Nifemi, are you there? Okay. Who
yes,
else? Who else wants to tell me what they learned in today's class?
Me,
me, sir.
Okay, please go ahead. What did you learn from today's class?
We learned how to calculate our valence electrons, the outer shell, glass shell.
Mm-hmm. Beautiful, beautiful, beautiful. Now, I said earlier on, when we were calculating the electronic configuration for lutetium, the elements that Francis picked, instead of us ending on the F block, we ended on the D block. Did you all notice that?
yes, sir.
And I said
Yes, sir.
Yes,
I said I was going to get back to that. So I want you all to check this out. Can you see what's on the screen right now?
summary and recap.
Yes, summary and recap.
How about now?
Yes, sir.
What's on the screen?
Yes, sir. Yes.
Plutonium's placement is debatable.
Debatable.
Okay. So normally, according to the law, the block that an element is located on, if it is located on the F block, in the electronic configuration, we are supposed to end on the same letter, right?
Yes, sir.
But we
Yes,
saw that
sir.
it was
Yes,
different for lutetium. So here is the reason. Despite its electronic configuration, can you see what I'm reading?
Yes,
Yes,
sir.
sir.
Good.
Sir.
Francis, do you want to read it for me?
Yes, sir.
All right, go ahead.
Chemical similarities.
Mm-hmm.
Despite its electron configuration, lutetium is often grouped with the lanthanide due to its chemical properties and its role at the end of the lanthanide series.
Good.
Periodic periodic table conventions. The placement of lutetium and lanthanum in the periodic table varies between publishers and textbooks. Some tables place them in the F block for consistency with the lanthanate series, while others place them in the D block based on their electron configurations.
So what they are trying to tell you is this. The reason why lutetium, that element that you picked, was placed in the F block, even though its electronic configuration ends with the letter D, was because its chemical properties are similar to the other elements in the F block. Did you get that?
Yes, sir.
And then some periodic tables, the way they drew them, that element, lutetium, is actually placed in the D block so that they can know that the electronic configuration of lutetium is showing that it is in the D block. Did you get that?
Mhm.
Yes,
So
sir.
it's not like we were wrong with the electronic configuration. We were actually very, very correct. But because of how the periodic table was drawn, its similarity with the other elements in the F block was what made us to see that difference. Are you cool with that now?
Yes, sir.
Yes.
All right. Did you enjoy today's class?
Yes, sir.
Yes.
Beautiful,
Yes,
beautiful.
sir.
I also enjoyed having today's
Yes,
class with
sir.
you. So our next class is going to be when? Do you know when it is?
On Wednesday.
On Wednesday, of course. If you're checking your timetable, our next class is going to be. Was it on Wednesday we had our previous class? I think it was on Tuesday.
On Tuesday.
It was on Tuesday. Our
Okay.
classes for SS2 are actually on Tuesdays and on Fridays. So on Tuesday, we're going to be
Okay, sir.
having our next class. Do you know what we're going to be treating there?
No, sir.
Have you checked your timetable? I actually sent a timetable for you guys.
Um, Actually, I have a question. Mr. David,
Yes.
in our last class, I asked a question and he said I should hold it for this class.
Oh, yes, please. What's the question?
I said that why is it those particular letters S, P, D, and F? Is there a particular reason or they just chose those letters?
Your voice is breaking. Can you please come again?
Okay, so I was saying that those particular letters S, P, D, and F, is there a particular law or principle that states that those must be the letters to be used, or they just science decided to use those letters?
Well, there are actually reasons why they are called SPDF. It's not like that they just decided, okay, let's just name it SPDF like that. No, no, no. There are actually reasons why they call this SPDF. Now, I'm trying to uh, um, read out something that I made, a research that I made to discover the reasons. The name of the atomic orbitals, S, P, D, and F, are derived from the terms that are used to describe the appearance of spectral lines observed from them. S stands for sharp, P stands for principal, D stands for diffuse, and F for fundamental. So, do you know the meaning of that word spectral?
No, sir.
Spectral, Spectral. Spectral is a word that is used to describe the appearance of an object under a spectrum. Do you know what a spectrum is?
Cool.
Spectrum.
Yes, sir.
Okay.
No.
Okay. Let me show you the definition on the screen right now. Allow me to. Can you see what's on the screen now?
Mm,
Um,
Yes.
yes, sir.
Okay,
Yes,
good.
sir.
Oh yeah, can you read it for me?
spectrum has several meanings, referring to the continuous range of light waves visible as colors.
Good. So now that you
Referring
know,
to the continuous.
yes, continue. Continue. Now, can you see what's on the screen now?
Yes, sir.
Yes,
Good.
sir.
Can you read that out for me?
The terms SPD and F for atomic orbitals are acronyms for their corresponding spectral line descriptions: sharp, principal, diffuse, and fundamental.
So,
These names were given These names were given to groups of lines observed in the spectra of alkali metals, and the letters correspond to the characteristic appearance of these lines.
good. So the lines when these elements. Can you hear me?
Yes, sir.
Beautiful.
Yes, sir.
The line, you can hear me, right?
Yes, sir.
Good. The lines that are produced from um, elements when they are placed on color spectrums, there are different descriptions that can be given to them. S here stands for sharp, P here stands for principal, D here stands for diffuse, and F stands for fundamental. So the reason why it is called SPDF, they are actually acronyms that stands for the corresponding spectral line descriptions. Are you there?
Yes, sir.
Do you
Yes,
understand
sir.
it now, or are you still confused?
Understand now, sir.
All right. Or you want me to send you a video for that?
Okay, sir.
All right, no
Yes,
problem.
sir.
At the end of the class, I'll get a video for you and then send it to you to understand. So at this point now,
Sir, sir,
yes,
please, I have one question.
yes, please go ahead.
You said you dropped the link for our assignment. Listen.
I dropped the link for your assignment now. Francis, did I not drop the link for the
Sir?
assignments?
Yes, sir.
I dropped the link for the assignment on the group.
I know he dropped it.
I didn't see it too.
You didn't see it. The one where I asked you to do the electronic
No, sir.
configurations for different elements.
I saw it.
No, I didn't see it.
Are you on the SS2 group or my community?
I just joined recently.
You just joined recently. Okay, I'm going to redrop it again after today's class, okay? I dropped the link
Okay,
actually.
sir.
I didn't know it was not everybody that saw it. I'm going to drop the link once again, okay?
Okay,
So
okay, sir.
here is what we're going to be treating in our next class. Can you see what's on the screen right now?
I'm still seeing some. Okay.
Yes.
On
Yes.
Tuesday, 9th of
Team of
September, we're going to be dealing with chemical bonding. We're talking about ionic bonds, covalent bonds, and metallic bonds. Okay?
Yes, sir.
Yeah.
Are you looking forward to the class?
Yes, sir.
Yes,
I
sir.
also am looking forward to the class. Thank you for being part of today's class. I will see you in the next one. And watch out for the assignment link that I'm going to redrop on the group, okay?
Thank you, sir.
Okay, sir.
Thank you for tuning in.
Thank you,
Bye-bye.
sir. Thank you, sir.